Welcome to the Building with Metal podcast, presented by McElroy Metal. Whether you're a contractor, architect, designer, or building owner, we're here to help you build better with metal roofing and siding products.
Welcome to another episode of Building with Metal. I'm your host, Kathy Miller, and today we're joined by Andre Desjarlais with Oak Ridge National Laboratories to dive into a topic that impacts energy performance in ways that many building owners and designers don't fully understand: roof reflectivity. During our session, we're going to cover topics like, how much does roof color really matter? Can a reflective roof actually lower my energy costs? And does it only make sense in hot climates, or can they be beneficial in cold climates too? Let's get started. Welcome to the show, Andre.
Thank you. Glad to be here.
Yeah, we're looking forward to our conversation for sure. Before we get started, though, in case folks aren't familiar with you and your role at Oak Ridge National Labs, can you give us a little bit of background?
I've been at Oak Ridge National Lab for about 35 years now. Presently, I am the program manager for residential building research at ORNL. But prior to that, I was in charge of building materials and systems research. So I've been involved in the energy performance of buildings in one way or another since my move to ORNL. Prior to that, I spent about 15 years as a energy consultant. Initially working with the aerospace industry during the heyday of the space program, but then transfer that information to buildings when we had our first energy crises back in the late 1970s. So energy has been my career, first on space missions and now on buildings. Buildings should be easy. They don't move, right? So, but the requirements are different. You know, in a aerospace application, cost doesn't matter. But try to convince a building owner that you're going to reclad his building and cost doesn't matter, and that's a difficult sell. So different limitations, both challenging from a different perspective.
Well, without a doubt, you bring an expertise to our listeners today that we look forward to unpacking. So before we do that, in case folks aren't familiar with Oak Ridge National Labs, could you give us a little bit of background on that and how they're structured?
Oak Ridge National Lab is one of, I believe there are 17 national laboratories that are spread out across the United States that are managed by the U.S. Department of Energy. So each one of the national laboratories has certain areas of expertise. Oak Ridge National Lab is, our expertise primarily is on building envelopes and building equipment, or a portion of what's going on at Oak Ridge National Lab is associated with building envelopes and building equipment performance. The National Lab is huge. There are about 7,000 employees at the laboratory. We're located just outside of Knoxville, Tennessee. And the lab was actually started as part of the Manhattan Project back in the mid-1940s. The laboratory was basically the research base for developing ways of enriching uranium for development of weapons of mass destruction, I guess was the term that was used back then. The procedures for doing that were developed at Oak Ridge, and the actual enrichment was done in Oak Ridge. Those materials were then sent out to Los Alamos, and those of you who have seen the movies associated with the development of the atomic bomb have seen primarily the testing portion of that story, but not the development story. And so the lab started as basically a nuclear weapons lab. In the 50s, morphed into a nuclear energy laboratory. And then in the 1970s became a kind of an all-purpose energy laboratory. And we kind of remain in that area today. Of the 7,000 people, probably only about 250 of those work in buildings. So buildings is really a small piece of what's going on at Oak Ridge National Laboratory. Fascinating.
Well, I know that as an industry, we count tremendously on the research that you guys do and your findings. And you know, as we're going to talk today, roof reflectivity has really continued to propel the use of products for, metal roofing and siding further. And we'll talk about some of the reasons why today. So before we get into that, Andre, can you talk to us a little bit about the research methods that you guys use there at Oak Ridge to evaluate how reflectivity impacts energy performance?
Yeah, the research in the area of buildings has been a topic at Oak Ridge since the early 1980s. And we were, I think it's fair to say, the first national laboratory that got involved in building energy performance. And so over the years, the Department of Energy has invested quite a bit of funding in terms of developing experimental capabilities to look at the performance of building envelopes. So our tactic usually is we have modeling capabilities, and a lot of the other national laboratories have modeling capabilities. But we can couple the modeling to experimental work. We can do experiments on the material level scale. So a good example of that would be if you want to measure the solar reflectance of a specific coating, we can do that. And, that requires a piece of the material that's probably, a couple of inches square. We can then put that on a piece of a building and measure that in the laboratory. So now we're looking at, if we're talking about a roof, maybe a roof that's roughly 12 by 12 feet in cross section. We have solar simulators in our laboratory, which allow us to mimic the energy which strikes the surface of that roof. And we can measure the energy benefit on kind of that scale. And then we also have access to buildings, whole buildings, where we can, again, take a roof coating or a roofing material, reclad the building, and then look at the overall change in the energy performance of an entire building. So we can do the experiments on multiple levels, multiple scales. And I think that kind of makes us unique compared to our sister laboratories, where they tend to focus primarily on the modeling side and don't have the experimental capability, primarily, I think, because the investment was made here. And obviously, the Department of Energy doesn't want to replicate that investment. There's no need to do that. So having the capability of looking at performance in multiple ways. If you model something, then you get an answer. If you test something, you get an answer. But if you do both and you can compare them and get the same answer, then that kind of gives you a lot of confidence in the quality of your measurements and your computer simulation work. And so I think that's what makes our laboratory somewhat unique.
Yeah, I would agree. I know, several years ago, McElroy supplied some material, for us to use in a physical building, right, to take and kind of confirm that other element in regard to the modeling. So I'm curious, Andre, how often does the modeling in the physical building results vary?
Although we're working for a national laboratory and in the public sector, our research is not really a whole lot different than a small company working and doing research. The Department of Energy effectively funds us, and projects kind of change from time to time. There was a lot of work done back on building color and cool roofing back in the mid 90s through maybe around 2010, and then the topic kind of cooled off. That's terrible.
No pun intended.
I didn't. No, I wish I was smart enough to make it intentional. But then recently, there's kind of been a kind of a renaissance. Today, there's a lot of activity trying to figure out ways of making buildings more energy efficient and having a fairly short payback. And changing the color of the building is typically a pretty cost-effective way of improving the energy performance of a building. And so we're kind of revisiting the idea of cool roofing. The ability of the materials have changed. They're better than they used to be. The performance improvements are better than they used to be. So it's time to peek at them once again. So we now have a new source of funding to kind of restart some of this work. And so it's not what we do tends to change depending on what DOE wants us to do and where the funds are.
So let's talk, without getting too deep in the weeds, right, with chemistry and whatnot, let's talk a little bit about color and why different colors matter from a reflectivity standpoint.
I'm not a chemist, so I'm not sure I could get into the weeds if you wanted
well,
me
that's
to.
a good thing.
So we'll skip that part. A building will absorb energy from the sun. The sunlight strikes the building, and the amount of energy that gets absorbed in the building is a function of what's referred to as the solar reflectance, which is primarily dictated by the color. The darker the color, the more energy that gets absorbed by the building. And in technical terms, that what we would say is that the solar reflectance of that dark surface is low. Solar reflectance is a number that varies from 0 to 100%. A building that has a solar reflectance of 0 absorbs all of the energy that comes from the sun. One that has a solar reflectance of 100 reflects 100% of the solar energy that comes from the sun. There are really no materials that are at the absolute extremes, but a dark colored surface, say a dark brown or a black, would have a solar reflectance of about 10%, which means that 90% of that energy is absorbed. A bright white surface would probably have a solar reflectance of about 80 to 90%. And so much more of that energy is absorbed. So if you're living in the South, like I am, and your energy bill is primarily cooling, then you don't want the building to absorb this solar energy. You want it to reflect off that solar energy, because that's any energy that gets absorbed increases your cooling bill. If you're in a northern climate, the opposite is true. You'd like to, certainly in the wintertime, absorb as much energy as you possibly can, because that would be offsetting the heating bill. So depending on where you are, you have, kind of, the United States is a big country, at least in terms of climate. And southern climates tend to want to have roofs that have high solar reflectances. Northern climates tend to want to have roofs that have low solar reflectances in general. And the building codes kind of reflect that. At least in the commercial building code, solar reflectances are giving you a credit in climate zones 1 through 3, which is basically the Georgia-Tennessee line south. In northern climates, they won't give you a credit for the color of a building.
And so let's break this down a little bit, if we could, for our listeners. Could we assume maybe a 2,000 square foot home? Are we talking real dollars here? Is it really enough to add up, Andre, as far as potential cost savings for choosing a light or reflective colored roof?
Yeah, so it depends on how old the building is, right? Because not only does solar reflectance impact the energy bill, but the amount of insulation that you would have also impacts the energy bill. So if you're building to code, the older buildings would have lower levels of insulation, and therefore the benefits of having a cool surface are increased. If you build to the most recent building codes, you're still getting benefits, but those benefits are diminished because the overall energy going into the building has been reduced by the amount of insulation that you have in the building. So we've done some calculations that kind of look at what the energy bill is. So for a residential home, and the building that we use is a 2,000 square foot 2-story building. You're probably talking about a couple $100 per year if you live in the deep South, Houston, Tampa, those sorts of areas. And the energy savings get smaller as you go further north, because your cooling requirements for the building decrease. Now, if you go to a commercial building, and the one that I always use is a 20,000 square foot strip mall. I don't know why. I guess I like shopping. I don't know. I haven't figured that one out. But your savings go up a lot because, for 2 reasons. One is that the building's a whole lot bigger. Right? It's 10 times the size of the residential building. But also, the amount of insulation that's required by code in a commercial building is lower than that of a residential building. So, again, using kind of Houston, Texas, Tampa as kind of a baseline, your savings goes from a couple $100 to a couple $1,000 per year. And again, as you go further north, those savings diminish. And and eventually, when you get far enough north, like Minneapolis, it's there's very little benefit in terms of having the color of the roof doesn't really matter a whole lot.
So that's fascinating. I was not aware that there was an energy code difference between commercial and residential, and that it was actually lighter at commercial buildings. That's very interesting.
Yeah, the cost of insulation, but for commercial buildings, you tend to need to have foam plastic insulations. And in residential buildings, in an attic, you typically use loose fiberglass products. The loose fiberglass products are a lot cheaper per R than the foam plastics. And so the codes are set such that the payback is reasonable. Since it's cheaper to put insulation in a residential building, the codes demand that you have higher levels of R value than you do in commercial building. So it's economically driven.
And so in a residential building, if I build, what is code required today for an R value in a residential? Do you know?
It depends where you are. In Tennessee, it's like roughly R50.
R50, okay. And so over time then, does that R value remain consistent in a residential application with the type of insulation products you're using there, or does it slowly degrade with time?
Generally speaking, it's the key for the performance of insulation is that it has to be installed properly. As with everything, right? If you do it right, then the performance it's pretty well constant. We've looked at some buildings that are 10, 15 years old and found that residential attics and found that the big thing with loose insulation products is that they will possibly settle with time. And so you put 2 feet of insulation in the attic, and then 10 years later you go back and you have 1.5 feet. So you've lost R value because of the mechanical settling. It's not a change in the material. It's a change in the overall thickness. And usually that is suggestive that the contractor who installed the product didn't quite do it right. He put in, it's an interesting business that you sell weight, but then you're applying volume, and you can play games with that. So I guess that was a nice way of saying that.
Yeah, I think you danced through that one well.
Okay, thank you.
I'll save you, and we'll change the subject here.
Yeah.
So you mentioned commercial buildings, and the fact that obviously reflectivity plays a much larger role there. I think for our listeners, anybody that's flown lately, as you come in over some of the airports, you'll notice that a lot of the big commercial buildings now have a white roof, right? Whether it's a membrane roof or a metal roof, and so to that end. They're taking advantage of that reflectivity. So I'm curious, Andre, though, does the roof reflectivity affect peak demand, or is it just consistent throughout the day?
It does impact peak demand. And this is a study that we've done fairly recently where we've looked at not only the energy savings associated with cool roofing, and this has been a topic that I think we've beaten to death for the last 20 years, but the issue of what it does in terms of, one of the issues at DOE right now is energy security. The demand for electricity just keeps increasing exponentially, and especially today, I guess if we say AI, that brings us into the 21st century, right? So, but a lot of the new computer capabilities are requiring significant computer resources, and the concept of data centers, which is something that's relatively new. These data centers use an incredible amount of electricity. So there's now an increasing concern about, do we have enough power? And because of the increased demand. So the interest in the utilities in particular have interest in controlling peak demand, because if they exceed their capacity, they have to go out on the market and purchase energy. And that price is always a whole lot steeper than if they're producing it themselves. So controlling peak demand has always been an interest in utilities. But today, if you're a commercial building, if you own a commercial building and you get your electric bill, these people are getting charged not only for the amount of energy that they use, but also for their peak demand, which is basically on a monthly basis, what is the largest amount of energy that's being required by that building over a 15-minute period. And you get charged per kilowatt for whatever that peak demand is. It's getting to the point today where a commercial user of electricity is probably paying an equal amount in terms of demand charge compared to usage. So it's not a trivial amount. It's not like it's only 10% of the bill. It's like half. And now this varies depending on what utility you're involved with that's supplying your energy and the specific program. They have lots of these demand charge programs, and I'm not sure how you negotiate and to get from one to the other. But it's a big cost. What we found was that if you put a cool roof on a building and look at demand, you see that in the South, the reduction in demand and the reduction in the cost that the building owner has to pay for demand is almost equal to the energy savings that the cool roof supplies. So again, it's not like a 10% number, it's half. And the interesting thing is that as you go north, you see these demand charge reductions even in Minneapolis. So in the past, we've always thought that, well, if I'm really far north, I don't need to consider a cool surface, a cool roof, because it's not going to give me any benefit. In fact, it might actually cost me money. But today, if you are paying a demand charge, reductions in demand charge I think you want to consider the use of cool surfaces, because from an economic perspective, you as a building owner might be saving money. You're not saving energy. You're saving the utility from having to produce extra energy or go out on the market and buy that extra energy, but you are saving money. And obviously, if you're a building owner, economics drives you, right? So this is the more important, I think, from a building owner's perspective than being a green citizen and saving energy.
So speaking of green citizens, let's talk about urban heat island effect. Any impact there? As communities, if they were to embrace reflectivity products, or is that kind of a new point?
The issue for urban heat islands is an interesting one because as an individual building, if you're in the middle of, I've been talking about Houston. I don't know why I've hung up on Houston today, but if you're in the middle of Houston, Texas, and you change the roof to a cool roof, you're probably not going to have a significant impact on the urban heat island because you're just one in a million. However, there have been studies that have suggested that if half the buildings adopt cool surfaces, and then you can start reducing the actual urban temperature. There's in areas that are heavily built, the air temperature is actually warmer than the surrounding environment, and that extra heat, again, during the summer, means that you have to cool more. So your energy bills go up. But then there are also a lot of sidecar issues that are difficult to quantify economically. As the air temperature goes up, you're more likely to have increase in air pollution. If you kind of think about Los Angeles and all their smog-related activities, those always occur in the summer when the air temperatures are higher.
So, that's a really great point, Andre. Let's dig into that a little bit. Can you talk to us a little bit about the reflective properties of products when they're new, versus 10 or 20 years downstream? And then also, does the reflective nature and their ability to maintain that reflectancy change by product type?
So there are several mechanisms that are involved in different products losing their levels of solar reflectance. The one that's probably has the greatest impact is the fouling of the surface. This could happen based on both dirt accumulation, dust accumulation, as well as the growth of biological materials on the surface. Think of a building that's next to a coal burning power plant, it's probably going to have a lot more dust in the environment, and the change in the solar reflectance of not so much of the coating per se, but that specific application would probably be greater than the same roof out in a cornfield somewhere where there's a lot less pollutants in the environment. The other issue that impacts changes in solar reflectance is physical changes in properties. There are a whole family of roof coatings that are produced in the marketplace today who have the intended service life is only 7 to 10 years. So as these products begin to age, they begin to degrade and their solar reflectance will be reduced with time. Then there are other coatings like PVDF, which have much greater service lives, and you don't see those degradations in the same time span as you would for roof coatings that are again have a planned shorter surface life. So there's an organization called the Cool Roof Rating Council, which creates a database of solar reflectance for different sorts of roof systems. And to try to address the issue of aging, they require that manufacturers of products supply them with solar reflectances after as the product is produced. So new product, and then also after they've been aged for 3 years. And this is an attempt to try to get a measure of the loss of solar reflectance as a function of time.
Yeah, I think that's really great that you brought that up, and a great resource for our listeners, right? If they're chasing products specifically with an intent or an eye to reflectivity, it's really important to consider that, the 3-year mark or the as in surface life. So, a couple other things, you mentioned the PVDFs, trademarked under different names, but obviously we use those, in our painted panels. It does make sense to your point that those hold up well because they're slick by nature, right? And so they tend to resist a lot of that dirt and that grime you talked about. So I'm curious, Andre, you mentioned, mold even in some cases can deter, which makes sense. Is it a best practice if somebody's chasing reflectivity to clean their roof every so often, if they notice something like that?
We've looked at that as and then again, this becomes an economical question. Obviously, to clean your roof costs money. And so then the question becomes, I am going to improve the solar reflectance, so therefore I am going to save more money in terms of my energy bill, but now I have to pay somebody to get the roof to be clean. What we found was that for most applications, the cost of cleaning was greater than the benefit of cleaning from an energy perspective, unless you're in a situation where, again, the hot, humid South, where you have a lot of biological growth, then you can lose a lot of your solar reflectance very quickly. In those applications, cleaning would be, I think you should consider cleaning. But if it's just dust cleaning or dirt accumulation, then just wait till the next rainstorm. The next hard rainstorm will remove a lot of that, and so you will get a boost back in terms of your solar reflectance. It probably won't be to the point where it was when it was new, but and especially if you have a smooth surface, an aggregate covered surface like a modified bitumen surface that has aggregate. Those are hard to clean because obviously you got all these little nooks and crannies, and dust can kind of get entrapped in those. But on a smooth surface, like a painted metal, the rainfall can remove a lot of the dirt. It won't remove the biological growth, but it will remove a lot of the dirt.
Yeah, that's a good point. Mother Nature can be a very economic wash clean or a clean.
Hey man, just put your car outside when it's dirty and hope for a hard rainfall.
So let's pivot just a little bit, right? Obviously, you've done a lot of work and have a lot of specialty in building enclosures, as well as energy over your career, Andre. So talk to us a little bit if somebody's really wanting to focus on reflectivity, what should they also consider in other parts of their building envelope to maximize their gains?
Well, there's interest now in looking at cool surfaces for walls. The benefits are not as great as they are for roofs because walls tend to be shaded If you have a lot of plants growing around the perimeter of your building, then that tends to shade the building. And if you don't have the sunlight striking the surface, then the benefit of having a cool surface is reduced. But there are benefits of going to wall surfaces that have high levels of solar reflectance. It's a second order benefit, but that's certainly something to consider, especially if a building is not shaded, if appreciably. So that's certainly an area that I think is important. One of the things that we're finding now is that, over the last, I'm going to say 15 years or so, the building codes have really, in the U.S., have really increased the requirements for insulation. So a building that's constructed to today's building codes is fairly well insulated, even compared to European standards. 15 years ago, we were embarrassed when we talked to our European counterparts because we weren't anywhere near as energy efficient as they were. But now we're on par with them. But what is now seems to be the biggest energy consumer for buildings is how airtight it is. So when you are recladding a building, I think it's important to consider improving the air tightness, putting an air barrier on, putting a water-resistant barrier on under your cladding material to reduce air leakage. And the payback for improving air tightness is typically in terms of a couple of years. So it shouldn't be difficult to sell those sorts of benefits to a building owner. We actually have a calculation tool on our website, and it's a free website. And you basically tell the program, where is the building, how big is the building, what are you paying in terms of prices for electricity and whatever your heating fuel is. And then you can say, okay, I'm going to improve the air tightness by 10%. It'll tell you what the economic benefit is, and how many dollars per year will the building owner save. And you can use this to hopefully convince a building owner that, especially if you're recladding, you've already got the wall available for this. This should be an easy sell if you wanted to pursue that sort of improvement along with changing the cladding.
Yeah, that's a great resource. And to your point, Andre, if you have the envelope opened anyway, that it's a perfect time. What is the website address where they could find that calculator, if you could?
Yeah, so it's ornl.gov/content, content/air-tight-savings-calculator.
Well, Andre, I know we've kind of been around the world, so to speak, today on energy. Any closing thoughts or other things that you want to make sure that our listeners know before we wrap up?
Well, besides the air tightness calculator, there's also another calculator on our website, which helps you estimate the energy benefits of putting a cool roof on a building. So it's a lot easier. It's just coolroof.ornl.gov.
Okay, well, Andre, thanks so much for joining our show today and kind of breaking up some of the myths about energy and reflectivity, and so that our residential and commercial building owners can make smarter decisions. If any of our listeners want to reach out to you directly, what's the best way for them to find and connect with you?
So my email address is my last name, which is a spelling test, but it's DESJARLAISA@ornl.gov. So just send me an email and be patient, because I get about 100 emails a day, but I will get back to you unless you have a research project for me. But if you have questions, I'd be more than happy to respond to those.
Fabulous. Well, thanks so much for joining us, Andre, and enjoy the rest of your day.
Thank you.
Thanks for listening to the Building with Metal podcast, presented by McElroy Metal. To stay up to date with our latest episodes, be sure to subscribe wherever you get your podcasts. Visit us online at www.mcelroymetal.com for more info and products. Until next time, keep building with metal.